Assalamualaikum. My name is Farah BINTI and I would like to present on my progress report on reduction of free fatty acid in sludge palm oil using glycolysis as biodiesel feedstock. So this is my progress for this semester. Okay, so let me just give you the brief of the study. So basically, what I'm doing is actually I want to use sludge palm oil to become a possible feasible feedstock for biodiesel. So commonly, biodiesel is produced from vegetable oils, but the challenges is the cost, which is high, and is unethical because vegetable oil are considered as edible. Therefore, we come up with sludge palm oil, which we get from palm oil mill effluent. So basically, SPO is a low quality oil collected from palm. So it is considered as cheap, and it's considered as the waste. So we can apply the concept of waste to wealth and apply the concept of renewable energy. But then the drawback is that this SPO has high free fatty acid, which is undesired in biodiesel formation and will cause formation of soap. Therefore, in order to produce biodiesel from this type of SPO, we have to reduce the FFA as minimum as 3% or lower. Okay, so what we did is we do glycolysis, which is adding glycerol at optimum condition to produce glycerides. So as you can see here, the glycerol that we get from the glycerin will react with the FFA with the high free fatty acid with the aid of zinc oxide as the catalyst to produce glycerides. So these glycerides will be used to produce biodiesel. So basically that's it. And then we will do the biodiesel through transesterification using methanol. So these are the problem statement. So the first one is the depletion of petroleum due to the high reliance as source of energy. And then the utilization of vegetable oil as biodiesel feedstock that resulting in high cost of production and high amount of FFA in SPO that affecting in low yield of biodiesel, and the common method of reduction of FFA using methanol has its drawbacks. Therefore, we use glycolysis. So these are the three research objectives, which are the first one is to determine the physical and chemical characteristic of SPO. So that we can assess if it is actually feasible for the production of biodiesel. The second one is to investigate the effect of temperature, autoglycerol mole ratio, and catalyst loading to the reduction of FFA in SPO using glycolysis. And the third one is to assess the feasibility of treated SPO as biodiesel feedstock by undergo transesterification. So these are the scope of the study. So basically, we utilize waste, sludge palm oil, which is collected from wastewater treatment plant in Terengganu. So, and then we will characterize the SPO, which is the first objective. So the significant characteristic that we want to analyze is FFA, acid value, color and moisture content, fatty acid composition, functional group, and triglycerol composition profile. And then we will do the glycolysis using zinc oxide as heterogeneous catalyst. And then we will do three significant parameters, which are temperature, catalyst loading, and all to glycerol molar ratio. And then we will do the transesterification. So for the research methodology, for the objective one, these are the example results. These are the experimental setup. We use heat plate to heat up the reaction, and then the condenser to remove the moisture, and the thermometer to monitor the temperature. And then for each hour, we will test for the FFA to get how much the FFA has been reduced within hourly. So these are the experimental setup, the heat plate, the condenser. So yeah. So these are where the glycolysis happen inside this flask. For the third objective, we will take the most optimal result and we will undergo the transesterification. We will use methanol at 65 degree for 3 hours. Okay, so for the first objective, this is the results. Sorry, these are the checklist. So basically, I still haven't got a chance to do the HPLC because of the constraint on the machines, but we will do it as soon as possible. Okay, so for the summary of the results, so the SPO has the FFA of 36%, has a value of 79%, functional group similar with the CPO, which means it is feasible. Fatty acid composition had the majority of fatty acid and moisture of 1.5%. So for the second objective, this is the method, but then we will change and manipulate the parameters. So for the challenges for the second objective, so it is only significant to do certain parameters to analyze its efficiency and its optimal condition. And for the parameters, why we take this ratio is to analyze if there is excess glycerol, if it is 50%, if it is 100% excess. Like how does this excess um, will affect the result. And then the temperature, we know that it must in high temperature, but then 250 is too high for the process and we disrupt the process, so we will take these three range. And the catalyst, this is actually the standard catalyst loading, and excess amount higher than 1% is not significant. So for the second objective, we finally got the final FFA result. So we can see here, temperature wise, if it is 170, it can achieve the what we want, the desired FFA, which is below 3%. But then if we compare from other temperature, 170 might be the lowest, which means that high temperature affect vigorously to the result. This is due to the kinetic energy. And then for the catalyst loading, we can see that the result is it correlate with the temperature, but then we can see that higher catalyst doesn't necessarily give higher result, which means that low catalyst loading still will give a significant result, but then um, temperature wise also affect the catalyst loading effect. Okay, so and then for the ratio, we can see here, obviously at 100% excess, we can see that at higher temperature and at higher catalyst loading, we get the lowest FFA. So for the third objective, we successfully produced the biodiesel using undergo transesterification by using methanol. We heat up the process to 3 hours at 65 degrees Celsius, not so high temperature. So this is how it looks when after we produce. So we just put it into the separating funnel to decant the glycerol and other sediment to get the pure biodiesel. So this is how it looks after we decant and wash the biodiesel. So we will physically wise, it looks the same as the SPO, but then we will do FTIR to analyze and prove the production of biodiesel to get if we actually get this fatty ester to prove the production of biodiesel. So in conclusion, SPO has the potential to become the biodiesel feedstock due to its promising characteristic. Only we need to improve its quality by reducing the FFA. And then we can say that temperature contributes strong influence to the FFA reduction. High amount of catalyst does not necessarily give better result, and ideal amount is sufficient. But then other parameter also influence the result. FFA is lower at higher temperature, but higher than 220 will disrupt the process. And then excess of glycerol help in reducing the FFA efficiently. And then we can see that biodiesel can be produced from SPO with low FFA. So this is the Gantt chart. So basically, I think I just have to like touch up here and there, and we can. I hope that I can get the thesis done by this September. So for the publication, as actually I'm in the midst of submission to a journal. For the thesis writing, I'm working on the literature review with the current journals while updating the result and discussion. So for next semester, so what we haven't done is HPLC. I will do the HPLC for both SPO and treated SPO, and then FTIR for the produced by diesel, and get review paper done to publish, and I will continue the thesis writing. Thank you.